The following is a production of Texas Lutheran University. For more information, please visit tlu.edu.
You guys know that I'm kind of water obsessed, so today's talk is all about, little tiny bit water obsessed. It's about my favorite molecule, the water molecule. We have Brent Doty, who is the Senior Education Outreach Specialist?
Coordinator.
Close. For the Edwards Aquifer Authority. He got his undergraduate degree in Geology from Brigham Young University, which I learned is not only in Utah, it's also in
Idaho and Hawaii.
Hawaii. Are they related? Or?
Yes, they're all like sister campuses.
So, who knew? But he's working on a master's in education at UTSA, and then does all of these fabulous presentations educating people in the area about the Edwards Aquifer. He will tell you all about the Edwards Aquifer Authority, so I'll turn it over to you.
Thank you. How you guys doing today? Good? It's great to be with you. Just a little bit more about how I got into this sort of thing. When I first went into my undergraduate program, I was nervous about chemistry. I didn't like it, and so I went into geology, and little did I know, I ended up having to take quite a bit of chemistry. 3 semesters of chemistry, 2 semesters of physics, and 2 semesters of calculus. So there's no getting around it. So it's good to be here with the chemistry department. And chemistry I find fascinating now. And actually biology I'm getting into too. Back in school, as a geologist, you kind of wanted to move, we wanted the green stuff out of the way. We just wanted to see the rocks. And now I have an appreciation for the green stuff too. So I've been studying aquifers for the better part of 10 years now. So 5 years in school and high school, and then 5 years now for the Edwards Aquifer Authority. So even though I went to school all the way out in Idaho, we actually studied the Edwards Aquifer in my program because the Edwards is one of the most prolific karst aquifers in the United States. It's very well known, and it has very unique features. And so I'm going to talk to you about those today. Now, I'm a visual learner, and that's why I brought this model with me. Kind of looks like an ant farm, but I'll show you a little bit more of that later. And although I have a PowerPoint, it's mostly photos and videos because I don't like reading off slides and that sort of thing. So I brought a lot of neat photos and videos to show you, okay? So first of all, aquifers and groundwater. In Texas, groundwater is a huge deal. All these different colors and shapes on here, those all represent different aquifers. So there are about 40 major aquifers here in Texas. Now the largest one up here, this is the High Plains Aquifer, and it goes all the way up to South Dakota. It's also known as the Ogallala, but I think that's why they nicknamed it the High Plains, because nobody could pronounce that, Ogallala Aquifer. But all these aquifers, they share some things in common, and they also have some differences. An aquifer is basically a layer of rock that's saturated with water that humans can use. So all of these are different rock types, and they're saturated with enough water for humans to use. Now, see if you can follow me here. And I don't know who named these. It was probably some geologist forever ago. But we have the Edwards Trinity, the Trinity, and the Edwards. Those are 3 separate aquifers. And we also have the Carrizo-Wilcox, and Wilcox, also 3 separate aquifers. But our aquifer is right here. It's the Edwards, and specifically we're talking about the San Antonio segment. It's actually divided into 3 parts that goes from Brackettville in Kinney County, or from Del Rio all the way up to Waco, but we're talking about this section right here today. So when we talk about how old the Edwards Aquifer is, I took a photo to help you figure it out. So I took this next photo in an undisclosed location in the Edwards. Okay? Anybody recognize that? It's a big dinosaur print. So here's my sunglasses for reference. So this is a big old dinosaur print, actually in the Trinity limestone, which is a little bit older than the Edwards. But the Edwards is right around the age of the dinosaurs, about 65 million years ago. About 100 million years ago, this area was covered by a warm, shallow ocean. And over time, sediment from the ocean accumulated at the bottom and later lithified or turned into rock and became what's known as the Edwards. Now, our section of it extends from about Bracketville all the way up towards Austin. So it's about a 180-mile section of this limestone rock. And the limestone is about 400 to 600 feet thick. Now, what's unique about limestone as opposed to other types of aquifer materials is limestone reacts with the rainwater. You guys, the chemistry majors in here, know all about this, but the rainwater is already slightly acidic, and it forms a weak acid called carbonic acid when it mixes with compounds in the soil. And because the limestone is made out of this calcium carbonate, it reacts with that carbonic acid and releases bicarbonate, and it dissolves the limestone out. And so we have all sorts of caves and sinkholes and disappearing streams and other features that allow the water to sink into the ground here. Now, if you're from this area, you know about things like Natural Bridge Caverns and some of these other show caves around. These are massive caves. Some of the largest caves in Texas are right here in our area. And beneath the ground in the San Antonio area is the Edwards Aquifer, which is basically a network of caves, kind of like you see in my model here. Caves and other conduits that are full and saturated with water, enough water for lots of people to use. In fact, about over 2 million people every day use the Edwards Aquifer. So it produces some of the most water here in Texas in terms of aquifers. Now, on my map here, I've got 3 different colors. We've got green, which is the drainage area, blue called the recharge zone, and yellow for the artesian zone. It's called the artesian zone because there's a lot of hydraulic pressure here. There is a rock above the Edwards, kind of like clay, that confines it down there. So you got water coming in from high elevation and nowhere for it to go, so it's like pushing down and building up a lot of pressure. And that's a good thing when you're talking about aquifers, because if there's already pressure in the system, artesian pressure, you'll have free-flowing wells and free-flowing springs. That means you don't have to spend a lot of energy and money pumping the water out. In some areas, wells just free flow. Now, this blue area I'll be talking a lot about, the recharge zone. That's where the aquifer is actually exposed at the surface. That's where the water enters the aquifer, and it's also the most environmentally sensitive area. So it's not just water that can enter the aquifer. Any kind of soluble chemical, anything like that can get into the aquifer as well. Bacteria, hydrocarbons, those are all concerns. So this is the area where that would happen the most. So I'll be talking about all those things. Now, if you take a knife and you just slice through the map like that, it looks kind of like this, a lot like my model here. We've got our first area, the drainage area. This is the Texas Hill Country. Now, the Hill Country has its own aquifer systems, but essentially, as the water enters the ground, there's kind of this impervious or layer of rock that water can't be transmitted through. So the water moves laterally and comes out as water table springs. It enters the watersheds here. Well, those move south and they cross the recharge zone, and that's where the Edwards limestone is at the surface, and that's where it infiltrates or sinks into the ground. A lot of these streams that seem pretty big at first end up as tiny creeks as they cross over here. Most of their base flow is being lost to the groundwater. So rivers like the Frio River, Saco Creek, Medina River, they all lose water as they cross the recharge zone. And then you notice these lines here. Those are faults. This aquifer is also known as the Balcones Fault Zone Aquifer. There are hundreds of faults that crisscross this area, making the geology quite complicated, but what it also does is drop the aquifer deeper underground. In some areas, there are freshwater wells as deep as 3,000 feet below the ground. And most of the freshwater wells are all in this area, the artesian zone. That's where we have that good pressure, and that's where the rock is completely saturated. So a lot of people ask me, are we ever going to run out of water? The answer is no. It could stop raining right now, and there would be water for years and years and years. This is 400 feet thick, 180 miles long, and completely saturated with water. So why do we worry so much about the aquifer dropping, and why do we have water restrictions and all this stuff? I'll get into that, but it has a lot to do with maintaining that pressure and those springs that free flow that I was talking about. We want to keep that pressure up, and we want to keep those springs flowing for a lot of reasons. You guys have all seen the drainage area in one way or another. If you've been up to Bernie or Lakey or any of these hill country towns, that's a very steep and rugged terrain, a lot of hills capped with limestone, And you'll actually notice an absence of water in a lot of places because the water is actually underground in a lot of places in the hill country too. Now, the recharge zone. I took this photo out in Uvalde County. That's a very rural county, quite west of here, closer to Mexico. Now, this recharge zone looks very similar across the whole aquifer, very steep and rugged as well, because there are a lot of faults. Now, the difference between this photo here in Uvalde and one that could be taken in San Antonio would be the absence of freeways, houses, amusement parks, parking lots, all of that. So it's quite different out here. Now, do you think that sort of thing might cause any issues with the aquifer? Well, there's a couple concerns I can think of, and that's if you start paving over sinkholes and you pave over caves, there might be less recharge entering the aquifer, less chance for that rain to soak in. Also, when it rains and that rain goes across a parking lot and picks up who knows what on the parking lot, oil, antifreeze, you name it, that stuff's got to go somewhere, and if it's on the recharge zone, there's a chance it could get into the aquifer. So because of these concerns, we have a lot of rules about how stormwater is managed, how wells are drilled on the aquifer, all the different kinds of rules in an effort to protect the water that enters the aquifer. We want to protect the water quantity and quality in the aquifer. So I mentioned before the different features like sinkholes and caves. So here's one example of that. Okay, this is a sinkhole in Medina County. That's about a 2-hour drive from here. And this sinkhole is 40 feet across, about as wide as this classroom, and 150 feet deep. And this is one way that water enters the aquifer. Every time we get a good rainstorm, this is actually a man-made channel here to help enhance the recharge, but this feature here is all natural. And there are hundreds of sinkholes and caves in the Edwards. In Bexar County, there's about 400. So this is just one way it gets in there. That's millions of gallons of water going in there. Now this is something I like to catch people's attention about. When it pans back over, I'll show you something. So right here, you see that grate back there? That metal grate right here is to stop debris like trees and other types of garbage from getting into the aquifer. And at the bottom of this, when it's dry, you can rappel down and go exploring down here. There used to be this telephone pole down there. Now, I don't know who put that in there, but if you can get telephone poles and cave explorers and trees in the aquifer, you better believe you can get oil and chemicals and pesticides in there too. There's a common misconception that groundwater is perfectly filtered, that you can put whatever you want in the ground and the rocks will just clean it up. And a lot of aquifers are really good at that. Aquifers that have very tiny pores and the water moves really slow. They do filter quite a bit. But this aquifer has caves and passageways larger than this room, and in some areas the water could be moving more than a mile per day underground. So that means there isn't a lot of filtration taking place. That means whatever gets in the aquifer, you're likely to be pumping it back out. So it's very vulnerable to contamination. This is one of the best aquifers for pumping, and it's one of the most sensitive in terms of its vulnerability to contamination. So we do watch that. Now this aquifer also has some really great springs. Anybody recognize this place? Nobody? Yeah, that's right, San Marcos Springs. Right here, it's about 30 feet deep. So that's crystal clear water coming out of the springs. And you can see it's dark all around here and light right here. This is actually one of the spring openings. So I think it was about 100 years ago, they constructed a dam here for a mill and turned this into a lake. But when the first people saw this, this would have looked like a river with a huge fountain shooting out of it. There are dozens of springs around here, and this spring puts off an average of 200 cubic feet of water per second. That's a lot of water. That'll fill this room up in no time. So a lot of the water in the aquifer is discharged through the springs. So we drink a lot of it through the wells, And we use a lot of it on our crops, and a lot of it is allowed to go into the springs. And that's for good reason. These springs are important to humans. The water goes downstream, and downstream users use it for electricity. They use it for drinking water. And it makes its way all the way to the coast and provides fresh water to the estuaries. Now, you biologists know how important that saline interface is between the fresh water and the saline water in the estuary. So if you don't have this fresh water entering the coast, it messes things up, right? So it's very important that our springs keep flowing. Now here's another example. This is Comal Springs, or one of them anyways, in Landa Park. And this spring actually recently went dry just a couple weeks ago. And it was all in the news because this is the most notable spring. Now when people see this, they kind of think that this is the only Comal spring, and that's not true. There are actually dozens and dozens of these in the lake there. But this is the most, I guess, visual spring. You can actually see the water coming out of the rocks. And so people got really worried about it. But the thing is, when our aquifer level drops below the elevation of the springs, well, it's going to go dry. So we take some steps to kind of prevent that or slow that down. And one other example, San Pedro Springs in San Antonio. Now, all these springs have been important to humans for thousands of years. They found artifacts here dating to 10 to 12,000 years back, human artifacts. But they're also important ecologically. There are endangered species, animals found nowhere else on Earth, nowhere else even in Texas, that live in these springs. There are salamanders, little tiny fish called fountain darters. There's a type of rice called Texas wild rice that only grows in the upper reaches of the San Marcos River. So very unique habitat. And if you're familiar with the Endangered Species Act, it's a federal law that mandates protection for species in danger of extinction. So we have that here. Now, okay, this kind of looks like a geyser, like Old Faithful, right? This is actually a water well that was drilled in the Edwards Aquifer in the early 90s, and it was called at the time the Catfish Well because it provided water to a catfish farm. Now at my house, on a monthly basis, I use between 6,000 and 8,000 gallons of water, okay, on a month. This well here was producing 30,000 gallons of water a minute flowing out of the ground, just naturally flowing out of the ground. And at the time, this area was under what's called the rule of capture, which is still the main governing law for water today in Texas and everywhere except for the Edwards. And what that law means is you can have a big well like this and pump as much water as you want as long as it's beneficially used. So in other words, as long as it's not being wasted, it's not going into leaving your property or things like that. So it doesn't matter if you drilled a well like this and you dried up somebody else's well or you dried up a spring. None of that matters. It's treated like a property right or a mineral right. And so at the time, when this well was drilled and it was producing all this water, it kind of caught people's attention, to say the least. And it wasn't just this one well. There were other things going on. At the time, Texas was in a drought, much like today, and a lot of people were worrying about the management of the aquifer. So there was actually a lawsuit that came out of this. The Sierra Club, along with the Guadalupe Blanco River Authority, sued the Department of Interior over the protection of those endangered species. And they prevailed in the lawsuit. And the judge said, look, you guys have to either find a way to manage this or the federal government is going to manage it themselves. So we as Texans didn't take kindly to that, and of course, and we established the Edwards Aquifer Authority where I work. Now the first thing we had to do was limit the amount of water that can be pumped out of the aquifer. We had to find some kind of scheme or management scheme to help limit that water. As you know, this whole area, the population is increasing, and the average person uses between 150 and 200 gallons of water per day. So also our water use is going to increase. But guess what? Because of the permitting system, we can't pump more Edwards water than we historically have. So either we have to use conservation to reduce our water use, or we have to find different resources, and that's exactly what's going on if you look at your water utilities. They're either looking at other aquifers to pump out of, they're looking at desalinizing this salt water, they're looking at using some surface water areas, so a lot of different things because the Edwards is capped by a legal law, okay? And it all stemmed from stuff like this. This is that well today. So the owner of this well, he ended up getting millions of dollars from the city of San Antonio. They purchased his well and his water rights from him. So a lot of people are pretty astonished by that, but that's how it ended up. So this is the well today. It's now a monitoring well, and you can see it still has a lot of pressure when it's turned on, but luckily it's usually turned off. So how do we keep track of the aquifer? If you ever watch the local news during the weather segment, they'll tell you the level of the aquifer, and they get that from a single well in San Antonio called the J17 Index well. And that well is deeper than the Tower of Americas is tall, so it's a pretty deep well, and it goes deep into the Edwards. And because of that pressure, the water goes up the well column, okay? And if we're getting rain and we're not using a lot of water, the level rises pretty quick. But if there's no rain and it's the middle of the summer and everyone's watering their yards, well, guess what? It drops pretty quick too. This is a very dynamic aquifer. Not all aquifers work like that. Some aquifers, people are just basically mining the water. It never recharges. Here, our aquifer recharges every time it rains on the recharge zone or on the drainage area. It refills. So we do have that, which is good. But the bad part is it also leaves pretty quick. It leaves through the wells and the springs. So right now, the aquifer is about 640 feet above sea level in this well, and that's where we take it from. Now that's about 25 feet below where it normally is. So even though we've had pretty good rains this fall and this year, we're recovering from a drought that stemmed from 2011, the hottest and driest summer on record, or one of the hottest and driest here. And the aquifer just dropped like crazy. So right now we're pretty near historic lows. There was a drought back in the 1950s that made Comal Springs dry up, all the springs, for about 6 months. And during that time, all the species in Comal Springs were lost. All those endangered species, they all died out. Luckily, San Marcos kept flowing, and when Comal recovered, they transplanted those species from San Marcos into Comal and established them both. But if the drought ever got severe enough, we'd lose both springs and all the species, and we're trying to prevent that. So one thing we do is called critical period management, and that means the lower this well gets, the more we issue out pumping restrictions. So right now we're at a 35% cutback in pumping. That means if you're a well owner and a permit holder, you have to reduce your pumping by about 1/3. That's kind of a big thing. If you're a city and you're allocating 100% of your permits to your pumpers, then they tell you that you have to cut back your pumping by 1/3, you really have to get creative with what you do. And so you'll see things like you can only water your car or water your lawn on certain days or at certain times. You can't wash your car. All these different water restrictions to cut back in your pumping. Now we even have this thing called stage 5 critical period. So if this well gets too low, we'll go into a stage 5, which is a 44% reduction. That's huge. And it's all in an effort to slow this down so the springs keep flowing so wells don't dry up. It's a really big deal. Kind of hard to see on here, but every little green dot here is a water well. There are thousands of wells in the Edwards Aquifer. Some of these wells are for irrigation out west here. Some are for residential use, businesses, so a lot of different uses. Sometimes these wells cause us a little bit of problems. Here's a few examples. These are called abandoned wells. Abandoned wells are deteriorated wells that haven't been used possibly in decades. Sometimes they're open at the surface or cracked around their foundations. Sometimes they're leaking out water like this one, and this one is actually just filling up a lake, you know, for no reason. And this one was in downtown San Marcos. Now the real problem with these is contaminants from the surface could possibly enter the well and get down into the aquifer like this. So here's our abandoned well on the left and our active well on the right. Chemicals might get down that broken casing, get into the Edwards, and be pumped up an active well. And this has actually happened before. Wells have been tested positive for PCE, which is a contaminant that comes from dry cleaning chemicals. And one of the ways that that could have happened is getting down through one of these wells. That chemical is denser than water, so even though there might be pressure here, it's going to sink down and get into the aquifer. So we actively look for these wells. Landowners bring it to our attention, And we get these things either repaired and back into service or completely plugged because they are a real hazard to the aquifer. Now, another problem like this. I took this photo on the recharge zone. I don't know about you, but I don't want stuff like this on my recharge zone. Okay, this is a bunch of leaking oil barrels. So we have rules about how chemicals can be stored. They have to have secondary containments. They have to be inspected, so we don't get stuff like this going on. Now, even though we have all these rules, there are a lot of people that live on and around the recharge zone, and so you're going to have some accidents. And here's just a few examples. This is hydraulic fluid leaking from a train here. This is a traffic accident, and I was actually at this one. This is diesel fuel from a truck tipping over. It's about 300 gallons of diesel fuel on the recharge zone. And right down here is the entrance to a creek. So when this stuff happens, the Edwards Aquifer Authority, we're not first responders that cleaned it up, but we do make sure that it's cleaned up properly. So in this case, the hazmat team installed a dam here, and they vacuumed all this stuff up. And we immediately start sampling the water all around the accident. We sample for weeks. In this case, we're looking for hydrocarbons. This is a nasty sewer spill, but since we're eating pizza and stuff, I won't make you look at that one. But when this stuff happens, we're sampling the water to make sure that this stuff didn't get in there. Remember, I said the water can move about 1 mile per day in some areas. So if an accident happens and a day goes by, that contaminant could have traveled 1 mile in the aquifer. That's huge. It's very hard to track once it gets in there. It's very hard to find it. Obviously, you can't see where it's going. One thing we do, though, is called dye tracing. So he's not dumping diesel in the aquifer. This is a type of dye. A lot of plumbers use it to check for leaks in your home. But we use it in caves and sinkholes to test the aquifer. So it disperses as the aquifer flows. And we use spectrometers to look for the smallest amount of that in wells all around the area. And if the dye shows up in any concentration in that well, it means that if this were an actual contaminant, it would have eventually wound up in that well. So we can tell how fast the aquifer is moving, where a contaminant would possibly go if it entered the aquifer. So we know which wells will be affected if something happens. We can shut those wells off before a potential contaminant gets there. So we do this all over the aquifer. Another thing we do is biological monitoring. So you biologists, if you're not going to med school, there are other options. These guys, they take a look at the springs and look at our species. Now, one of the things they're running into now is invasive species. These are animals that don't belong in the aquifer. If you've ever had a run-in with fire ants, you've met an invasive species here in Texas. Another problem here in the springs, there's actually a type of snail that infects the gills of the fish and kills them. And so these guys are trying to find ways to get rid of those invasives. But once they're established, they really do well here. The water's clean, constant temperature, and there's all these little salamanders for them to eat, which happen to be one of the endangered species. So they look at that. We do a lot of different sampling. We don't just sample water levels in that one well. We test dozens of wells. This is one of the salamanders I was talking about. He's called the Texas blind salamander. And part of that original lawsuit was that we would eventually have to have a plan in place to protect these guys. And this is called the Habitat Conservation Plan. Very original name. But it was meant to bring everyone together and agree upon how we're going to manage this system. So the Habitat Conservation Plan isn't solely proposed by the Edwards Aquifer Authority, but it has regional partners like New Braunfels, San Marcos, Uvalde. So it has the irrigators, it has the municipal users, and everybody had to agree on how to do this. So it has a lot of different parts to it. One of those parts is called the aquifer storage and recovery. So there's another aquifer south of here called the Carrizo-Wilcox. And when the aquifer is very full, San Antonio will pump a lot of its water and inject it into that other aquifer. So right now, like when the aquifer is low, we use that storage instead of pumping from the aquifer. So about 1/3 of San Antonio is running off this saved supply instead of pumping from the Edwards. It's pretty neat. It's one of the largest ASRs in the world. So that's just one part of the HCP. And then another thing that we do is conservation easements. The City of San Antonio purchases development rights of ranches west to protect the recharge zone. So that means the owner can continue to ranch and continue to live on his land, but he can't ever turn it into a subdivision or a golf course or anything like that. So there's about 100,000 acres enrolled in that program that will always stay like this in their natural state, which is good for the watershed. And finally, I wanted to show you guys this slide. Like, again, if you're not going to med school, I know a lot of you guys are into that. But we have a lot of different careers. We have geologists, lab analysts, data analysts, modelers, environmental scientists, a lot of people that work in the aquifer, and there's a lot of good positions there. So, before I move on to the model, does anybody have any questions for me? Yes?
So, parents live over the recharge zone, and since there's not like a whole lot of like gas stations like around, I've noticed, do they just like double barrel their gas tanks underground?
Well, for a long time, there was actually a ban on any new tanks at all. So you couldn't have an underground or above ground storage tank on the recharge zone. For years and years and years, it was like that. So you'll notice there aren't very many on the recharge zone, and there still aren't because there's a lot of rules about it. Now we do allow above ground storage tanks, but they have to have secondary containments, they have to have leak detectors and all this other stuff, and they have to be inspected all the time. And for good reason. And I'll show you that in the model. You'll see what happens when a leaking tank.
There's still a ban on underground, you can't put any.
Yeah, no new underground tanks. And no new, or you can't use coal tar-based sealants on roads. So in Comal County, they were using a lot of these tar-based sealants on the roads, and we were detecting that stuff in the water, so we banned that too. Yes? You have a question?
Oh, no.
Okay. Anybody else?
I saw in your one picture of the broken well picture,
Uh-huh.
you see the the Eagle Ford Shale.
Yes, Eagle Ford Shale.
Can you just make any comment about the Eagle Ford Shale and potential impacts from fracking that?
Well, fortunately, I guess for us, most of the fracking and the oil production is south of the aquifer and the saline zone of the aquifer. So the fracking doesn't affect us too much. Now, I know a lot of other people are concerned, like Carrizo users, because the Carrizo is right around that area. And there was a study done by the EPA out of Wyoming that showed that fracking was impacting the aquifer. So we're definitely concerned and watching it, but thus far it hasn't affected the Edwards.
And wouldn't necessarily like just change the, I guess I'd be worried about it changing like the hydraulic connectivity, you know.
Yeah, we're definitely keeping an eye on it, but so far it hasn't happened.
And Seguin is on the Carrizo. correct?
Yes. Mm-hmm. Yes.
Have you ever done any studies like regarding how much like water they're actually using, like doing fracking? Because I know to frack one well, it takes thousands of gallons.
Oh, it takes more than that. Yeah, it takes a lot of water, and they don't disclose necessarily how much water they're using because remember, the rule of capture, if they're not using Edwards water, they can pretty much do whatever they want. Did you have a question?
Yeah, I did. For the recharge zone, the Hill Country mentioned that it kind of runs off into the recharge zone. But what kind of rot prevents the water from draining? Because you said limestone in the recharge zone can get through the limestone, but what kind of rot can it not get through?
It actually is. It's actually another type of limestone. It's just a denser form of limestone. Limestone, when it doesn't have those dissolution pockets, those caves in it, has the porosity of about concrete. Okay, it doesn't really have a lot of pores in it. So if that limestone isn't susceptible to cave forming, it's going to be really impervious. The water's going to go laterally, and that's what we see. And that's in a formation called the Glen Rose, which isn't like that all the way across. In some areas it does form caves, like at Natural Bridge Caverns. Okay, I'm going to show you guys the ant farm over here. So this is just like that cross section I showed you. We've got the drainage area here. Here's our recharge zone, and here's our artesian zone. Okay, and that all kind of feeds into, this is our spring over here. So I've got our well pump hooked up, so we can pump our water. See that? So this is one of the wells. So we also have, we've got an underground storage tank like you mentioned, and here's another one here. And this well right here is one of those abandoned wells. So the casing is broken at the top. And then we have some deeper wells which represent like a city well. So what I'm going to do, I'll add some diesel fuel or some kind of fuel into our underground storage tank. And you can see what happens, okay? We're going to start pumping our water again. Not so cool, right? So this is why there was a ban on those tanks for a long time and why we were so worried about it. If those tanks leak, that stuff's just not going to stick around there, you know? It's going to flow and get into the wells, and you see over here the spring's turning red now too. So this is it's a dynamic system. It moves, it flows. Now, in another case, now this tank here is exactly the same way. It's leaking, it's constructed the same. The difference is that this tank is in the artesian zone well above the Edwards. So I'm going to put this in there. And you can see for the most part it's contained. But remember, over here, this is our abandoned well. So you can kind of see it. It's starting to go across the topsoil there. I can speed it up a little bit. Oh, you can start to see it now. It's going down that abandoned well. So even though the tank was far above the Edwards, the stuff still found a way to get down this well and get into the aquifer. And that's why we're so worried about abandoned wells, because there are hundreds of these things all across the aquifer. And there's also a lot of susceptibility. There's a lot of areas where contaminants like this could get out. So that's one thing we worry about. Another thing is these caves and sinkholes. If people put garbage and stuff in those caves and sinkholes, well, that has the same effect, you know. It's going to get in there. Now these are kind of worst case scenarios, but a more common thing might be this non-point source pollution that I referred to in the one slide about impervious cover. Parking lots and houses that use a lot of fertilizers and pesticides, oil dripping from cars, antifreeze, all that stuff kind of adds up and it goes all over the roads, and so when it rains, all that washes out into our watershed. Now if we don't have best management practices like drainage basins and things in place to help filter that, that stuff can impact the aquifer just as much as one of these point source scenarios. So that stuff can also get into the aquifer. So we have a network of dozens of monitoring wells that we sample all the time. And we sample them for bacteria, for different types of chemicals. We check the temperature, the pH, connectivity, dissolved oxygen, all these different parameters to make sure that the water is staying as good or better than it was the day before. And if we find something wrong, we have to find the source as soon as we can. And we have to notify people downstream of there if their wells are going to be impacted. Unfortunately, that doesn't happen very often. The water here is very, very clean. In fact, it exceeds all drinking water standards, and it has to do with drainage area. Most of the water comes in from a rural area. It's not very developed, so it's basically really clean drinking water that enters the aquifer. So what do you guys think? Are you freaked out about drinking the water now? Yes?
What do y'all do with like the abandoned wells that y'all like find or someone reports them and y'all like somehow?
We work with the landowner to find a driller, and they make the decision whether or not they want to keep the well. Sometimes they want to keep it, and so they have to redo the casing that's inside the well and put a new pump in it and stuff. But a lot of times they just want to get rid of it, and so what they do is they put gravel down on the part that's actually in the water, and then they fill this part with cement, so nothing can get in there. But that can be kind of expensive, which is why a lot of them will just, you know, kind of stuff a burlap sack down the well and cover it over with dirt and hide it. Well, that's great that you can't see the well anymore, but that casing is still under the ground, so it's still there. Yes?
what do you do with like tanks, like gasoline tanks and stuff that are leaking? Do y'all like how do y'all A know which one is leaking, and B how do y'all go about replacing?
Well,
fixing them?
I'm not as familiar with the tank program, but I know they monitor it. For example, a gas station, they know how much gas goes out into the cars. And so if they check their tank and they're coming up missing 500 or 1,000 gallons of gas, they know there's something wrong. But they also have leak detectors now, alarms that go off when tanks leak. And we inspect the tanks pretty regularly. So there are a lot of things in place. The tanks that exist on the recharge zone now are very well regulated, extremely. But in other parts of the U.S., there's a huge problem with these tanks. Some of these tanks were built in the 40s or 50s, and they're just not going to last that long. And so, yeah, they're going to have leaks. Okay, you guys have been a great group today. If you want, I brought some different things if you want to pick them up. But thanks for letting me talk to you about the aquifer, and I'd be happy to answer any questions you might have afterwards.
Students at TLU engage in high-impact educational experiences that include civic engagement, aesthetic expression, critical thinking, and a focus on intercultural knowledge in a community that welcomes the interplay of faith and reason.